This lesson is on how to factor a quadratic when your lead coefficient is not 1. So you see here our lead coefficient is 2. So step 1, you're going to multiply your A term by your C term. So step 1, 2 times 12 gives us 24. So now we want to look for the factors of 24 that when added give us our B term. So the factors of 24 are 3 and 8, 2 and 12, 6 and 4. But again, we're looking for a sum of 11, so we found it here with 3 and 8. It's tempting at this point to say, yes, I'm done. You are not. This is just another step in the process. So step 3, rewrite the quadratic using the factors from step 2. So I'm not going to change the value of anything. I'm just going to rewrite it into a different form. 2x squared plus 8x plus 3x plus 12. So all I've done is rewritten 11x as 8x plus 3x. Now it doesn't matter which of these you put first, but I like to put the terms together that seem to go better with one another. So 2 and 8, 2 goes into both 2 and 8, 3 and 12, 3 goes into both 3 and 12. It just makes it a little bit easier. So now we're going to factor by grouping. So I'm going to focus just on this piece first. So what's common to 2x squared plus 8x? Well, I can factor out a 2, and I can factor out an x. And that leaves me with, so remember when you factor out a term to determine what goes in this set of parentheses here, you're just dividing by whatever you factored out. So 2x squared divided by 2x is just x. 8x divided by 2x is just 4. And now I'm going to focus on this side. So what's common to 3x and 12? 3. And that leaves me with, so I factored out a 3, so 3x divided by 3 is x. And 12 divided by 3 is 4. So now, notice how these are both the same values here, x plus 4, x plus 4. It's not a coincidence. If you are able to factor by grouping, this will happen each and every time. So if this doesn't happen, you know you've made a mistake. So now, x plus 4 is common to both terms, so I'm going to factor out an x plus 4. So again, remember when you factor out, you're just rewriting it. So I'm going to divide both of these by x plus 4. I'm left with a 2x. Divide by x plus 4. And I'm left with a 3. So my factors are x plus 4 times 2x plus 3. My x-intercepts, if that's what the question is asking you to find, would be -4. And this one's a little trickier. You might actually have to write the equation out to see that value. So what value of x will make this 0? So subtract 3 from both sides. So 2x equals -3. X equals -3 halves. Okay, let's go ahead and practice with one more. So again, step 1, multiply your A term by your C term. So 2 times -4 gives us a -8. So what are the factors of -8 that when added give us our B term, which is -7? Well, factors of 8 are -8 and a +1, +8 and a -1, 2, 4, or -2, or +2 and a -4. But we can already see, we know we need a sum of -7. So that is going to give us our sum of -7. So the next step, we just want to rewrite this using these factors. So I'm not changing the value of anything, I'm just rewriting it to make it a little easier to factor. And keep in mind, not every quadratic is factorable. So if the question asks you to factor it, it's okay to assume that it is indeed factorable, but not all quadratics are. Plus x minus 4. So see, I didn't change the value of anything, I just spread that out a little bit, -8x plus x. And notice I put the 8 next to the 2 because they just seem to go well together. So here I'm going to factor out a 2x. 2x squared divided by 2x is x. negative 8x divided by 2x is negative 4. So here, we don't have anything to factor out, but you see these do look the same. And that's where this can get a little bit tricky. So we're going to go ahead and factor out a 1. And then that leaves us with x minus 4. So now what's common to both? X minus 4. So I'm going to factor out an x minus 4. And I'm left with 2x plus 1. So if the question is asking you to identify the factors, these are the factors. If the question is asking you to identify the x-intercepts, we would have 4, 0. And again, go ahead and set this one equal to 0 and solve. So 2x equals negative 1. X equals negative 1/2. So negative 1/2, 0.